Good morning student. In today's video, I am going to explain third lesson of algebra arithmetic progression. First we see the definition of sequence. Now what is the sequence? A sequence is a collection of numbers arranged in a definite order according to some definite rule. This is the definition for the sequence. Now here I write some example. From this example we understand which are the set and which is not the set. Now 1, 2, 3, 4, 5 set of number it is given. If I will ask the question what is the next number after the 5, so your answer is 6. Because this set of number is according to the definite order and the definite rule. Therefore what is the next number? So we can easily tell the answer is 6. Okay. If we see the second example. Second example is given 1, 2, 4, 8, 16. Then what is the next number? Then your answer is 32. Because these are the multiple. This 1 into 2 that is 2, 2 into 2 that is 4, 4 into 2 that is 8, 8 into 16 that is 8 into 2 that is 16, 16 into 2 that is 32. Therefore set of number in this example are according to some definite order and a definite rule. Therefore this set of number is also called a sequence. This first example is also sequence. What about the third example? In third example numbers are given 1, 4, 9, 16, 25. Then what is the next number? If you observe this number, here we see these numbers are the perfect square number. This is the 1 square, this is 2 square, this is 3 square, this is 4 square, this is 5 square. Therefore next number is what? 6 square, this is 36. Therefore these numbers also according to some definite rule, some definite order. Therefore this set of number is also called a sequence. Then what about the fourth example? Numbers are given 1, 4, 3, 9 and 7. What is the next number? Okay. Now these numbers are not in definite order or the sequence or the definite rule. Therefore we can't find the next number. Okay. Therefore this set of number is not the sequence. Okay. Now students, I hope you understand what is the sequence or which set of the numbers is called a sequence. Now next topic is arithmetic progression. This is the name of lesson, arithmetic progression. Now what is arithmetic progression? We write in short A, B. The sequence, arithmetic progression is the sequence in which the difference between two consecutive terms is constant. This is very important. The sequence in which the difference between two consecutive terms is equal or constant, then that sequence is called an arithmetic progression. Okay. Now see, if you see this example, now example 1, 2 and 3, these are the sequence. But in this sequence, the difference between this consecutive term, 2 and 1, difference is 1, there is 1, there is 1, there is 1. Difference between two consecutive term is constant, then that sequence is called the arithmetic progression. Now if you see the second example, here this set of numbers are the sequence, but the difference between this consecutive term is not constant, therefore this is not the arithmetic progression. Okay. Now here we write some example 1, 2, 3, 4, 5. Okay. Now in this example, if you see the difference between two consecutive terms is constant, therefore this is called the arithmetic progression. Another example 2, 4, 6, 8. This is the sequence and the difference between consecutive term is constant, therefore this sequence is called an arithmetic progression. Okay. Now we see some example from practice set 3.1. Here I explain the first question. What is the first question here? Which of the following sequence is an arithmetic progression? This means some examples of sequence are given there. You have to identify which sequence is an arithmetic progression. If it is arithmetic progression, then we have to find out the common difference also. Okay. Now here I take first example from question number 1. What is the sequence is given? 2, 4, 6, 8. Okay. Now you have to identify this sequence is an arithmetic progression or not. Now the terms of sequence are represented as first term as T1, second term T2, third term T3 and fourth term T4. That is 2, 4, 6 and 8. First we find out the difference between two consecutive terms. Therefore, second term minus first term, that is T2 minus T1, 4 minus 2 is equal to 2. Then next two consecutive terms, T3 minus T2 is equal to 6 minus 4 is equal to 2. And T4 minus T3 is equal to 8 minus 6 is equal to 2. Here we get the difference between each consecutive terms is constant or equal. Therefore, we can say this sequence is an arithmetic progression. Therefore, we have to write the difference between any two consecutive term is constant. Therefore, this sequence is an arithmetic progression. And the common difference. Now, what is the common difference between two consecutive terms? That is 2. And here we have to write the common difference. It is represented as D is equal to 2. Okay. Now we see the second example. Now second example, sequence is given to 5 upon 2, 3, 7 upon 2. Here we represent the first term T1, that is 2. T2 is equal to 5 upon 2, second term. Third term T3 is equal to 3. T4, fourth term, that is 7 upon 2. First we find out the difference between the consecutive terms, that is second term minus first term, that is T1 minus T2 minus T1 is equal to 5 upon 2 minus 2. By cross multiplication, here we get 5 minus, there is 1. Okay. Therefore 5 into 1, here we get 5. 2 2s are, here we get 4. 5 minus 4 upon 2 is equal to 1 upon 2. Similarly, we find out the common difference between third term and the difference between third term and the second term. Therefore, T3 minus T2 is equal to 3 minus 5 upon 2 is equal to 6 minus 5 upon 2 is equal to 1 upon 2. Then next, fourth term T4 minus T3 is equal to 7 upon 2 minus 3 is equal to, by cross multiplication here we get 7 minus 6 upon 2 is equal to 1 upon 2. Again here we get the difference between the consecutive term is constant. Therefore, this sequence is an arithmetic progression. And the common difference for this sequence or arithmetic progression is 1 upon 2. Okay. Now we see the fourth example. Okay. Now what is the fourth example? In this sequence 0.3, 0.33, 0.333. Okay. This is the sequence given. First here we represent the terms of the sequence. T1 0.3, T2 0.33, third term T3 0.333. Okay. Here we find out the common difference. Here we find out the difference between the consecutive terms. Therefore, T2 minus T1 is equal to 0.33 minus 0.3. This is equal to 0.03. Okay. And then the difference between the next two consecutive terms, T3 minus T2 is equal to 0.333 minus 0.33. Here we get the answer 0.003. Okay. Here we see the difference between two consecutive terms is not constant. Therefore, we write the difference between any two consecutive terms is not constant. Therefore, given sequence is not an arithmetic progression. Okay. Now we see the seventh example. Now what is the seventh example? Sequence is given 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. Here we represent the terms of the sequence. T1 first term, that is 3, second term T2 is equal to 3 plus root 2, third term of the sequence T3 is equal to 3 plus 2 root 2, and fourth term T4 is equal to 3 plus 3 root 2. Okay. Then next step, here we find out the difference between two consecutive terms. Therefore, T2 minus T1 is equal to, what is the second term, that is 3 plus root 2 minus T1, that is first term minus 3 is equal to, here 3 and minus 3 will cut and what is remaining? Root 2. Then T3 minus T2 is equal to, third term is 3 plus 2 root 2 minus second term. Second term is there minus 3 minus root 2 is equal to Now 3 and minus 3 will cut. 2 root 2 minus root 2 is equal to what? 1 root 2. That we write root 2. Then next difference between next consecutive term t4 minus t3 is equal to, what is the fourth term? Sorry, t4 minus t3. Fourth term is 3 plus 3 root 2 and third term is 3 plus 2 root 2. Here we have to do subtraction, therefore minus 3 minus 2 root 2 is equal to, here we can cut 3 and minus 3, then 3 root 2 minus 2 root 2 is equal to root 2. Again here we get the difference between two consecutive term is constant, therefore given sequence is an arithmetic progression. Therefore, and the common difference for this arithmetic progression is d is equal to what? Root 2. Student, I hope you understand all these example. Remaining example are the homework from question number 1, that is 3, third example 4, sorry 5th, 6 and 8. Remaining questions from this exercise we will see in next video. Thank you very much.